and then move on to the next section, the final section for this week. I really was hoping that I would be 100% fit or 90% fit today so that I could turn up in person tomorrow, but I'm already dying. That's an exaggeration. I'm already getting worse as the day goes on. So I know that even if I turned up to class tomorrow, I'd probably be good for the first couple of classes, but by the time I got to you lot, I'd be no use to anybody. And so for that reason, one more day. And I'm very confident that I'll be good for next week. But just to remind you, Monday is Martin Luther King Day, so that's a holiday. So I won't actually see you now until Tuesday. So bear that in mind. Tuesday is going to be the next time you see me in person. Fingers all crossed. And I will be doing one more lesson through Zoom right now. And today's my last day for my antibiotic as well. So I'm assuming that when I take the last one, it will have kicked out everything that's causing me issues. So we talked about this at the end of yesterday, and there's these things called Z-scores, and we're going to do some more calculations on them. And then we're going to finish by using SALT, not only to calculate Z-scores, which is kind of nice because it means you don't need to do it by hand, it'll do it for you. But a much cleverer thing that SALT allows us to do is it allows us to find the proportion that's greater or less than a given value. So I'll give you a kind of heads up of what kind of question this is going to be. Suppose we know that the mean IQ is 100. And let's say that the standard deviation is 20, right? So there's this IQ test where the average is 100 and the standard deviation is 20, and that it's normally distributed. We know it looks like that. And we know that right in the center is going to be 100. And then you go 1, 2, 3 standard deviations, 1, 2, 3. And you would get numbers like 120, 140, 160. You get 80, you get 60, and we get 40. And we've got that really ugly looking table that we could use to figure out what percentage is in the last group or what percentage is these two and so on. But what we can now do using SALT, which is statistical analysis, something, as it stands for, is I can tell you the proportion. So if you like, the fraction of people who have an IQ bigger than any number I like, or an IQ less than any number I like. And the answer I'll be able to come up with will be, since it's a proportion, that's just a fancy way of saying it's a decimal. It might be that this answer here is 0.38, and maybe this answer here is 0.67, right? That would be the proportion they're talking about. Me personally, I don't like proportions. I prefer percentages. So 0.38 is like 38%, and 0.67 is like 67%. So I'll be able to tell you things like the number of people who have an IQ bigger than 111 is 38% of the population. The number of people who have an IQ less than 123 is 67%. So I don't need to do, 1, 2, 3 and build this weird table. We can get all the answers we want by just using a piece of software that's got programmed into a way of deciding, a way of calculating these proportions. So we can find out the proportion that's greater or less than a given value. So let's begin. Let's do a Z-score question, right? Now for a Z-score question, you need to be told the mean, and you need to be told the standard deviation. And then you're going to be asked to find the Z-score. So this would be an example of this would be question 12. And then you're going to be asked to find a Z-score. Would that be question 12? Am I in the wrong place? Yes, it is. Question 14, sorry. Then you'd be getting a Z-score, and they'd ask you for a Z-score for 500. formula for getting a z-score is the data, that's the number they gave you, take away the mean, divided by the standard deviation. So if you tell me it's 500, the z-score for 500 is 500, take away 400, divided by 50, and that ends up being 2. So the answer, what is the z-score for 500? The answer is that z-score is 2. If you are given the mean and standard deviation, you can find the z-score for any number, right? If I said to you, I'd like to get the z-score 120 or the z-score of 1,000, we would use this formula and we could get its z-score, right? Pretty straightforward. So let me give you some truisms. For most samples, right? So if you look at all your data, most of these samples will have z-scores in the range -3 to 3. So if you calculate the z-score of just a typical person from a population, right, from a sample, the z-scores tend to be in the range -3 to 3. It's the first truism. Second truism is, if your score is larger than the mean, right? So if your age is larger than the average age, then the z-score will be positive. So can you imagine this story up here, that the average is 400 and the standard deviation is 50? If I try to find a z-score of any number that's bigger than 400, I know that that z-score is going to be positive something. I also know that typically the z-score is between -3 and 3. And this is our last truism. If you get a z-score bigger than 3, like a z-score 4.2, right? A z-score is 7.9, right? If you get a z-score bigger than 3, or a z-score less than -3, right? Like a z-score -4.2, that kind of thing. I can tell you right now that that number, right, that data point is an outlier. So I now have a test to see if one particular number is an outlier or not. And all the test requires me to do is find the z-score. And if the z-score of that data point is bigger than 3, that data point, right, that guy is an outlier. If the z-score is less than -3, that guy is an outlier. So let's do some questions involving all those things. So suppose I have a mean and it's 500 and the standard deviation is, say, 20. The first question might be, find the z-score for 531. Well, that would involve us just basically using our formula. The data, which is m, take away the mean, divided by the standard deviation. So the data would be 531, take away 500, and then divide everybody by 20. And I am now going to make a mistake on my calculator. So let's have a look. if you hold on for a moment while I set up my calculator, and I said I'm about to do a mistake, a deliberate mistake on my calculator. And maybe you can tell me when you see it what I did wrong. Well, according to the calculation I just wrote down there, it's the data point 531. I'm going to take away 500, and then I'm going to divide the answer by 20. And the answer is not 506. In fact, do you know Z-scores are typically between -3 and 3? Wouldn't you be really worried about anything that gave me a Z-score of 500, right? What did I do wrong in my calculation then?
Order of operation?
Yes. So if you want to do it in one go, put a bracket around it and do 531 first, take away 500, finish the brackets, and then divide it by 20. So looking at that number, isn't that a much more realistic and reasonable typical Z-score, right? Most Z-scores are -3 to 3. So if you do a calculation and the Z-score's right way out there, you might have done what I just did there, right? You might have simply just hit a wrong button in your calculator. It's a very basic way of doing it, but you can check, and you know, anything that helps is good. And you're right, Alison, no parentheses. Although I call them brackets, but parentheses is what you lot call them, and you're correct to call them that. So the first question would be, find a Z-score for 531. No big. B, find a Z-score for 482. Now I'm about to do this one correctly. It's going to be the data. Take away the mean, divided by the standard deviation. And the data in this case is what? 482. The mean is 500. And it's going to be divided by 20. Before I hit any button on my calculator, why do I know that this Z-score is going to be a negative number? How can I tell?
Because the number is smaller than your mean?
Yeah. So if I accidentally think the answer is positive 1.2, won't I have another look at my calculator to see what I screwed up? So it's always a good idea to have a good visualization of what kind of numbers make sense and what kind of numbers are weird. So Z-scores of 500, forget it. That ain't happening. I screwed up, right? I know this should be negative. Why is it positive? I screwed up, right? And if you can detect mistakes and then go back and say, oh, God, I forgot to do this, or I forgot a bracket or whatever it was, it's great. It means you have, I know you get 5 shots, but you don't want to use all your shots up every time. So I'm going to put this one in over here, and I'll just tell you what the answer is. It's 482, then take away 500. And then I'm going to divide by, as we say, 20. And the answer is exactly what I thought it would be. It's negative 0.9. And I forgot what this guy is, but I believe he was positive 1. Oh, what was he? 1.55 there. Now, the next kind of question that you might be asked goes along these terms. Is a score of 580 an outlier? So we have a population, a sample of 500, standard deviation is 20. If someone had a score of 580, would they be an outlier? Now, what you don't have to help you here is you don't know the rest of the data. Can't you sometimes just look at the data and see this guy way over there on his own, and say, yeah, I'm pretty sure he's an outlier. What this does is it allows us to do a test. And the test is you find the Z-score. So it's going to be data, take away this guy, divided by 20. And the answer I got was 4. Now, if the z-score is bigger than 3, you're an outlier. So doesn't that qualify as bigger than 3?
Yes, sir.
Right? And so we can say 580 is an outlier. We can also say why. Because its z-score is greater than 3. 3.01 is still greater than 3, which means you are still an outlier, right? So you could be an outlier with a z-score that's almost 3, but if it's a little bit bigger. Let's do another one of those. Is a score of 479 an outlier? Well, let's see what the z-score tells me. 479, take away 500 over 20. It is a negative number. I'll tell you in a minute what it is. 479, take away 500, and divide by 20, and it's negative 1.05. Okay, is 479 an outlier now?
No.
No. And we can say it's not an outlier. And couldn't I write a sentence because its z-score is not less than negative 3, right? To tell you or to give you an example of how little z-scores vary, pretty much everybody, the vast majority, 99.7% actually, has a z-score somewhere between negative 3 and 3. If you start looking at z-scores like 4, a z-score of 4 will happen like 1 in 1,000 times, right? It's a very, very rare event. A z-score of 5 happens like 1 in 1,000,000 times. And a z-score of 6 is like 10 million times. Do you see that z-scores don't actually get that big, right? So when people are doing scientific experiments and they're using z-scores as a way of judging how unlikely this particular result is, right? If they get a z-score greater than 3, they might be a little bit suspicious that this experiment had some kind of mistake in it, right? Something wasn't measured correctly, right? It would be an outlier, right? But if you got a z-score of like 10, it either means you really screwed up on your experiment, or maybe you've just discovered something that no one else has found, because that is so unusual an event that maybe something interesting has happened, and maybe you should look into it. So that's the first part of today. Now we're going to use SALT to do these z-score stories. So I'm going to do an IQ story. For the IQ, the mean is going to be 100, and the standard deviation is going to be 20 in my story. And we, hold on a second. I'm going to click in here and find the page. Here we go. So the SALT that you're going to use is in question 13. And in my story, you've got a mean of 100, a standard deviation of 20, right? And in this story, we want to know what proportion get fall below an IQ of 82. And they also want to know what is the Z score for getting an IQ of 82. So I'm going to nip over here and show you how you can do all of those things without needing a calculator. Right, so you're looking at question 13.
Yes, sir.
Right, so I'm going to hit use salt, and this guy appears. So you don't need to go hunting for it, it's in front of you. The bell-shaped data has a lot of names. Wasn't one of them the normal distribution, right? So it's still the bell-shaped data. In fact, if I shrink this down a tiny bit, there, can you see it? Looks like that.
Yes, sir.
Now, in my story, we type in what the mean and standard deviation is, because each question, the mean and standard deviation is going to change. So in this story, the mean was 100 and the standard deviation was 20. And we want to know what's the chance that it falls below 82. Now, they call it probability, which is fine. So probability, proportion of times things happen. And we go to this guy here and we make it less than 82. Now, it's already set up for less than 82. Do you see less than 82? You can see visually it's less than, right? It's smaller. The answers that we were being asked to find are Z-score. Can you see the Z-score there is negative 0.9? So put the mean and standard deviation here and here. Look at the question. Do you want something below or less than? Use that guy. Suppose I'd like to know bigger than, right? You click this guy. And I'd like to know, I know, bigger than 82. Right? Bigger than, you can see in the picture, shaded to the right is bigger than. Less than. This here is the proportion that they're talking about. And the guy above it is, the guy below it is your Z-score. So your Z-score is negative 0.9. And the proportion of people who have that IQ or less is 0.18406. 0.18406. So if I was doing that question, Z-score would be here, approximate proportion. Do they mention what accuracy they want? Yeah, they want the answer to 4 decimal places. Okay. So let's do one of their questions. Question A has a mean of 500 and a standard deviation of 100. And they want to get that it's below what proportion of people would get a score below 470. So here we go with the guy. The mean this time is 500. The standard deviation this time is 100. Oops. And they want to be below. When it's below its left tail, when it's bigger than its right tail. Okay, so I want below, and I want below 470. So I go and I say, you can see it here, less than, below 470. And the Z-score is written down here as negative 0.3. And the proportion, what proportion of people in your sample would have that, ends up being this guy here, 38209. Now I'm going to take that and can I plug it in? No, oh, damn it in space. Okay, going to bear with me for a second. I'm going to have to go back in and do something from scratch. I'm going to go in and do a question and then hit submit just to show you that it works. So it's going to require a few bits and pieces that I kind of need to do to get there. Come on, hurry up. There we go. And here we go. I'm going to click on that one. I'm going to open student view, which is good. And I want to do bell-shaped data. And I'm going to zoom down to that guy at the bottom again. Here we are. Now the numbers change, so that means I'm going to have to do it again from scratch, but never mind. That 500 and the 100.
Can you lot still hear me? Can you hear me?
Yes, sir.
Okay, my speaker came up with a like battery going low kind of warning. Okay, so I want to be below 430 using this mean here 500 and this standard deviation of 100. So I'm going to have to hit this guy again. Okay, and it's going to change to 500. This is going to change to 100. It's less than, and this time it's going to be 430. And there's the z-score that they need, and there's the proportion that they need. So I'm going to see if I can move that out of the way. Good. Now, the z-score that we had was negative 0.7. And the proportion was 0.24196. So it was 0.24196. Now, since they're asking me to do it to 4 decimal places, I need to round this guy off. Well, after the 9, there's a 6, which means that rounds off. So that would be the answer rounded off to 4 decimal places, and submit answer. And we are good to go, right? Do you see it works? Now, in the next question, the mean is changed to 34. The standard deviation is changed to 1. And it's another one of those below guys. In the third question, the mean is 75. The 8 was this. And they want to know, oh, yeah, why don't they do? Yeah, they're all belows. I wish they had put in 1 above, but they're all below. So I'll just pick this one then as the final example. 75, 8, and 81. 75, 8, and 81. Okay. So the mean was 75. The standard deviation was 8. And they wanted to know what proportion of people would get a score, let's say it's a test, of 81 or less. And the z-score is 0.75, and the percentage of people would be that number there. And to 4 decimal places, 7734 would be your answer. Now, with that piece of software, if you just tell me the mean and standard deviation, I can tell you what percentage of people got bigger than this number or less than that number. And the proportion that they're given, if you think about that as a percentage, that's what, about 77% of the people, right? So proportion is just a decimal, percentage is that decimal turned into a percentage. Which now brings us to the end of that section. Is there any questions before I move on to the next section?
Are we ever gonna have to do that without the SALT software?
No.
Okay.
So when you get those types of questions to do in, say, an exam situation, they would be done in such a way that you don't need to use the SALT, right? It would basically be very difficult to do it otherwise. You need SALT. Right, now I'm going to move on to our next section. And our next section is chapter 3. So we're finished chapter 2. And it's a topic called scatter plots. And for what time I've got today, I'm going to do notes. I'm not going to do any questions, not going to look at the homework. We're just basically going to get you used to what a scatter plot is and the way we look at them and the vocabulary that we use, the terminology that we use. So let's start with what a scatter plot looks like. You will have two axes. Typically, you have your x-axis and your y-axis. Let's suppose in this story, the x-axis represents the age of children. And let's say the y-axis represents the weight of those children. And what you do is you go to, I don't know, a nursery school, you know, whatever, a primary school I would call them, and you collect data on lots of children and you say, how old are you, John? And weigh them. How old are you, Janice? And weigh, right? And you would plot each data point. So let's suppose that we start at 2-year-olds and we go 3-year-olds, 4-year-olds, 5-year-olds and 6-year-olds. So we're really talking quite young children, right? And you find a 2-year-old and you find the weight of that 2-year-old and you do it. And then you find a 3-year-old and a 4-year-old. And if you're 3.5, we'll do you as well. And if you're almost 5, we'll do you. And you plot a lot of data points. And we're being pretty accurate. So we won't just say you're 3 years old. We'll find out your date of birth and find out you're 0.4 years old, right? We can do it as a decimal. And you end up with that guy. That guy is called a scatter plot. It's basically a two-dimensional representation of two pieces of information. The x-axis here is the age of the children, right? And this guy is very often called the independent variable. And then for each child, you measure, in this case, their weight. And this is very often called the dependent variable. Now, if you look at lots of scattered plots, there are certain features that are very common to scatter plots, and we tend to give names to these features. So here is the first feature. Scattered plots can be positive, they can be negative, or they can be neutral. Now, a scatter plot that is positive basically means that the data is going uphill, right? It's increasing. As x gets bigger, so does y. And so that's positive. A negative scatter plot would be, right, things are going downhill. And a neutral scatter plot would be where there's no obvious going up or going down. Great. That's just pretty circular and random. Positive, negative, and neutral. You also find these are called positive associations. Association. This would be called negative association. And this third one is typically no association. In other words, there is no real obvious connection between what the X value is and what the corresponding Y value is. So can you imagine positive, negative associations, no associations, right? That's very common shapes that you get. Now, within positive or negative for that matter, there are two flavors of positive. The first one looks like that. And the second one looks like that. Now, I'm going to draw a line through them just to emphasize things. Now, when you look at these two different situations, they are both positive association, because as this X gets bigger, doesn't the Y get bigger, right? You're going uphill. In this case, you're going uphill and it's pretty much a straight line, right? In this case, aren't you going uphill, but it's much more curved. These are both positive associations, but they have different names. This is a linear association. And this one, and I hate this name, but it's the one that WebAssign uses, curvilinear. I wish they just said curvy association, right? Or something like that. I wish they'd used that term. But curvilinear association. Now, can you imagine that negative associations can also be linear? And can't negative associations be curvilinear? And no associations don't have any something going on, so we don't even talk about them. Now, the next thing that we do with scatter points is basically what's called the strength of the association. And they fall into very broad categories. There can be a weak, there can be a moderate, and they can be strong. Let's do strong. Strong would be when you look at the data, there's almost a perfect straight line or a perfect curve. Would you agree those data points are almost, but not quite in a perfect straight line, right? That would be strong. Now, if you go to the weak, I mean, it is still positive and it is kind of linear. Would you agree it's still straight line-ish? But would you also agree that there is not an awful lot of strength there, right? They're quite weak, the connection between them, right? There are a lot of variation on where the dots go. And then moderate kind of fits somewhere between those two extremes. So not as good as that, but better than this. So an example of a moderate might be this guy. Now, this is not real physics or real stats, but I'm going to tell you how my brain works. You put a sausage around the data. Skinny sausage, strong. Medium-sized sausage, moderate. Big fat sausage, weak. Does that kind of make sense if you're trying to visualize it, right? Now, the ones I've done are moderate, weak, and strong linear, right? But couldn't you also have curvilinear in the same situation? So just for one example, a really strong curvilinear might look something like this. Would you agree that's nice and curved and pretty tight, right? Nice and close together. A weak one, color scheme. A weak one might look, I'm putting in my basic starter, guys, right? Yeah, would you agree that's much worse looking, right? That would be considered weak. And you can, somewhere between those two extremes, you can put moderate. So we have a vocabulary now that allows us to talk about scatter plots. The vocabulary is positive, negative, no association, linear, curvilinear, strong, weak, moderate, right? So I'm going to draw a scatter plot, and we'll try and see if we can put the language that we've learned into describing this particular one. I'll use the green dots, they're much thicker anyway. Yeah. Okay. Positive or negative association?
Say negative.
Right, it's going downhill. So negative association. Linear or curvilinear?
Curvilinear.
Do you agree it's got a curve to it? The one that most people have a problem with is strong, moderate, or weak. But from those three choices, what do you think would be the most appropriate for this particular scatter plot?
It's pretty weak, no? It's pretty wide.
Yeah, it is
My-
pretty wide, but
in my
it could
opinion.
be worse. And you're right, yeah, there's a lot of judgment call in this. In this one, I would say moderate. Now, you could argue that it's, you know, that's moderate. This is about the same level. It's definitely not strong. I think we'll all agree it's not strong, right? There's far too much wiggle room in here, right? So moderate or weak. And if you are really on the fence, you can actually do a cop out and you can say moderately weak, which is just basically somewhere between these two, right? So if you really get stuck and you're not really 100%, is it weak, is it moderate, it's kind of on that cusp, just stick moderately weak. You can also have, can you imagine a situation where it looks really good, but you don't know if you want to call it strong or moderate? Couldn't you just call it moderately strong? And that would allow you to get around that as well. And that's all we have time for today. I will see us all online tomorrow, and we'll get to look at a little bit more detail about scatter plots. Until then, bye-bye. Oh, last name for attendance, almost forgot.
Thank
And
you.
then bye-bye. You're welcome. Bye-bye, guys.
Well, have a good day, sir.
I will try. Any questions before I call it a day and close off, guys? William, Juan, Tristan?
I have a
Uh,
question.
Yes, Juan, what's your question?
Do you do office hours, like
I
one-on-one?
do. I'm going to do office hours right now. If you want to talk to me in private, then leave this one and find the officer link and click on it, and I'll be there for you.
Okay.
Okay. William, have you got anything for I close this one off? Tristan?
yeah, I just had
Uh-huh.
a quick question. When I signed up for the class, it said it was online. And so I was wondering, is it next week or is it gonna be only in person?
Yeah, I'm going to be back to being fighting fit, and the class isn't online. The class is on ground. Should
All
be.
right.
Okay.
All right, thank you.
Anything from you, Tristan?
I had one quick question about the homework problem or a
Sure, what-
homework problem
Okay,
from
which one?
it's from numerical summaries, question 11.
Okay, let me find
there's
it for you. Hold on a second. I'll go and get yours, Tristan. That way, it'll be the numbers that you're seeing. Tristan, where are you? Tristan W. Okay, right. What question number was it now?
11.
11. Okay. Okay. So
So that the middle section for question 11b says the middle half of men reported an amount of exercise beginning with the lower bound of the range between blank and blank. I did the lower and upper fence equations using the quartile
You
1
did
and
good.
quartile
I-
3.
good. And what? It didn't work out.
No, it gave me a pretty heavy negative number for
Yeah, I
the
can
first
see that.
box.
Okay, so let me see if we can do this. So the middle half of men reporting an amount of exercise beginning with the lower bound of the range between 32 and 3:35 minutes. So the lower bound of the range is this guy and the upper bound is that guy. Okay, so let me write down the numbers that we would get from that. We need Q1. Oh, is 32. Oh, darn it, in space. Yeah, I can see what they're doing. Are you looking at your answers here right now? Can
Yeah.
you see them on the screen right now?
Yep.
The way that question is phrased, it looks like they're talking about the upper and lower fence, right? Which is this bit here that made you think that. But
Yeah.
if you read, it's not actually doing that. It's saying the middle half of men. Now, the middle half is from Q1 to Q3, right? That's the middle half. And so the numbers you should have used were just 32 to go here and 335 to go there. So it was just
Okay.
misinterpreting what they were asking, right?
Okay.
So the middle half is always going to be from Q1 to Q3.
All right.
Okay,
Yeah, the
was
way
it.
that it was phrased just made me
It
think that I
was.
was.
Yeah, I agree. The way I'm reading it, it took me 2 shots and the answer for me to figure out that the important part was this bit. And
Okay.
they really, that way that was phrased was a distraction. If they had just said, what 2 numbers are the middle half of the men, you probably would have went straight to 32 and 335 and not thought
Right.
anything in one. So, okay. We're good then?
Yep, we are all set. Thank you so much.
You're welcome. Bye-bye for now.
All right, bye.